ਵਾਹਿਗੁਰੂ। ਬੰਦੇ ਖੋਜ ਦਿਲ ਹਰ ਰੋਜ਼, ਨਾ ਫਿਰ ਪਰੇਸ਼ਾਨੀ ਮਾਹੇ। ਇਹ ਜੋ ਦੁਨੀਆ ਮਿਹਰ ਮੇਲਾ ਦਸਤਗੀਰੀ ਨਾ ਹੈ। O human being, search your own heart every day and do not wander around in confusion. This world is just a magic show. You will not get anything from it. Unit 2 Atomic Structure Part 4 by Amrik Singh, PGT Chemistry. Towards quantum mechanical model of atom. Two important developments which contributed significantly in the formulation of quantum mechanical model are: first one, dual behavior of matter, and second one, Heisenberg uncertainty principle. These are the two concepts which bring us towards the quantum mechanical model of atom. Dual behavior of matter. The French physicist de Broglie in 1924 proposed that matter-like radiation should exhibit dual behavior, both particle-like and wave-like properties. This means that just as the electron has momentum as well as wavelength, electron should also have momentum as well as wavelength. In the same way, we again repeat, this means that just as the photon has momentum as well as wavelength, in the similar way electron should also have momentum as well as the wavelength. De Broglie from this analogy gave the following relation between wavelength and momentum p of a material particle, and wavelength lambda is equal to lambda is equal to h upon mv, or h upon p. M is the mass of electron, v is the velocity of electron, and p is the momentum of electron. First note is that the Broglie prediction was confirmed experimentally when it was found that an electron beam undergo diffraction, a phenomena characteristics of wave. Diffraction is shown only by the waves, not the particles. This fact has been put into use in making an electron microscope, which is based on the wave-like behavior of electron, just as ordinary microscope utilize the wave nature of light. Note number third, an electron microscope is a powerful tool in modern scientific research because it achieves a magnification of about 15 million times. Note number 4. It need to be noted that according to de Broglie, every object in motion have wave character. The wavelength associated with ordinary object are so short because of their large masses that their wave properties can't be detected. Fourth point, just it is saying that this principle is applicable to both macro as well as microscopic particles. But for macroscopic particle, the wavelength is very small to be observed due to large mass. The wavelength associated with electron and their other subatomic particle with very small mass can, however, be detected experimentally. Heisenberg uncertainty principle. Werner Heisenberg, a German physicist in 1927, stated uncertainty principle, which is consequence of a dual behavior of matter and radiation. It states that it is impossible to determine simultaneously the exact position and exact momentum or velocity of an electron. Here dx multiplied by dp greater than or equal to h upon 4 pi. Dx is the uncertainty in position and dp is the uncertainty in momentum. It will be always greater than or equal to h upon 4 pi. Let's discuss some detail. The uncertainty principle can be best understood with the help of following example. Suppose you are asked to measure the thickness of a sheet of paper with unmarked meter stick. Obviously, the result obtained would be extremely inaccurate and meaningless. In order to obtain any accuracy, we should use an instrument graduated in units smaller than the thickness of sheet of the paper. Okay, if we want to note the thickness of a sheet of paper, the scale should have lesser least count than the thickness of the paper. Therefore, for that purpose, vernier screw gauge is the better option. Analogously, in order to determine the position of an electron, we must use a meter stick, calibrated unit of smaller than the dimensions of electron. Yes, to observe the electron, we can illuminate it with light of electromagnetic radiation. To see anything, we require light. To see the electron, the light used must have a wavelength smaller than the dimension of electron. That is, the wavelength should be lesser than the dimensions of electron. The high momentum photon of such would change the energy of electron by collisions. In other words, if I want to use the position of electron correctly, then I will have to use the radiation of lower wavelength, that means of higher energy. In this process, we no doubt would be able to calculate position of the electron, but we would know very little about velocity of the electron after collision, because photon when collide with electron, it will change its velocity. Significance of uncertainty principle. One of the important implication of the Heisenberg uncertainty principle is that it rules out the existence of definite paths and or trajectories of electron and other similar particles. Note 1. The effect of Heisenberg uncertainty principle is significant only for the motion of microscopic objects and is negligible for that of macroscopic. However, it is applicable to both microscopic as well as macroscopic, but it has significance only for micro. Trajectory of an object is determined by its location and velocity at various moments. Since for subatomic objects such as an electron, it is not possible simultaneously to determine the position and velocity at any given instant to an ordinary degree of precision. It is not possible to talk of the trajectory of the electron. Trajectory means to know the location and velocity at various moments simultaneously. It is not possible for the electron. Classical mechanics and quantum mechanics. Classical mechanics, based on the Newton's law of motion, successfully describes the motion of all macroscopic objects such as falling stone, orbiting planets, which have essentially a particle-like behavior. Classical mechanics fails when applied to microscopic objects like electron, atom, or molecules. This is mainly because of the fact that classical mechanics ignores the concept of dual behavior of matter, especially for subatomic particle and the uncertainty principle. Classical mechanics do not take into account the dual nature of matter and the uncertainty principle. Third one is the branch of science that take into account this dual behavior of matter is called quantum mechanics. I repeating again, the branch of science that take into account this dual behavior of matter is that dual behavior wave-like and particle-like is called quantum mechanics. Quantum mechanics is a theoretical science that deals with the study of the motions of the microscopic objects that have both observable wave-like and particle-like properties. It specifies the laws of motion that these objects obey. 5. When quantum mechanics is applied to macroscopic objects, the results are same as those from the classical mechanics. Quantum mechanics was developed independently in 1926 by Werner Heisenberg and Erwin Schrödinger. Next is Schrödinger wave equation for the motion of electron in three-dimensional space around the nucleus. Schrödinger put forward an equation called Schrödinger wave equation, which is the heart of quantum mechanics. D square psi dx square plus d square psi dy square d square psi upon dz square plus 8 pi square m h square e minus v psi equal to 0. This is known as the Schrodinger wave equation, where psi amplitude of the electron wave, v is the potential energy of electron, E is the total energy of electron, m is the mass of electron, and d square psi upon dx square, d square psi upon dy square, d square psi upon dz, second derivative of psi with respect to x, y and z axis respectively. Quantum mechanical model of atom. Quantum mechanical model atom is the picture of the structure of the atom, which emerges from the application of the Schrodinger wave equation to atoms. The following are the important features of the quantum mechanical model of atom. The energy of electron in atom is quantized, that is, can only have certain specific values. The existence of quantized electronic energy level is the direct result of wave-like properties of electron and are allowed solution of Schrodinger wave equation. Third one, both exact position and momentum or exact velocity of an electron in an atom cannot be determined simultaneously. The path of an electron in an atom therefore can never be determined or known accurately. Okay, fourth point is an electron wave in atom is represented by the wave function psi. Psi is simply the function of coordinates of an electron, therefore it does not have any physical significance. An electron in an electron can have many wave functions in an atom, therefore there are many atomic orbital in an atom. The probability of finding an electron at a point within an atom is proportional to the square of the orbital wave function, that is psi, at that point. Greater the value of psi square, greater will be the probability of finding the electron at that region or at that space. Standing, we are seeing the electron wave can be compared with the wave formed in a string whose two ends are fixed. We are seeing a standing wave, that is the electron wave, and the traveling wave that is shown, that is not the electron wave. Electron wave is the standing wave formed in the string whose two ends are fixed. Some homework is there, numerical problems are there. बुरा भला कोई न कही जय, छोड़ मान हर चरण गही जय. Swayed by ego, we shouldn't slander or praise anyone. Instead, shedding our ego, we should enshrine God's name in our heart. किसी को बुरा भला ना कह, किसी की निंदा ना कर, ना किसी की तारीफ कर. अहंकार को त्याग कर, ईगो को त्याग कर परमात्मा के चरणों को पकड़ो. Thank you, धन्यवाद for listening the lecture.